front of you. Let me know when you can see that and if that matches what you want to work on.
Yep.
All right, so slope of a tangent line at the given point. So you still don't know any derivative rules, is that right? Or is this, which section are you in?
2.1.
So do you know how to take derivatives is the question.
I think that's what we were learning. We just learned about the tangent line problem, the derivative of a function, and the differentiability and continuity.
Okay, so what I'm trying to get at is there are two ways to do this problem. One is the limit as delta x goes to 0, f of x plus delta x minus f of x all over delta x, like that.
Yeah, I think that's the way that
Or yeah, or you'll learn the derivative rules, and I mean, depends on your book, but it's after the first chapter. But so okay, so to do this, we did this before. You have to find f of x plus delta x, which is 3 minus 5 times x plus delta x, like that.
Right. Okay.
All right, so that is, when we simplify, it becomes 3 minus 5x minus 5 delta x. And that's what goes in the numerator here. So it's the limit as delta x goes to 0, 3 minus 5x minus 5 delta x minus f of x, which is the 3 minus 5x all over delta x, like that.
Right.
So then in the numerator here, that you distribute the negative in, so it becomes minus 3 plus 5 delta x. And you can see the 3 and the minus 3 cancel. The 5x, not delta x, the 5x and the minus 5x cancel, and you end up getting the limit as delta x goes to 0 of minus 5 delta x over delta x, like that, which is minus 5.
Okay.
Is that okay?
Yep.
Right. So what does this mean? That is the derivative. Okay. The derivative is the slope.
Oh yeah, and then we just plug it in, right?
So you have to write the equation of a line. So the most common form of the equation of a line that you use in this course is point slope form. And this -5 is the slope. So it becomes y minus y1 equals -5 x minus x1, like that. And then that's where the given point comes in. The given point is -1 comma 8. That's your x1 and your y1.
Oh, okay.
That's your y minus 8 equals your -5 x plus 1, like that. That is it. That's the answer.
Will we not simplify it at all?
It's usually okay to leave in point slope form, which is
Okay.
what is given here. If they don't specify the form, you can do whatever you want.
Okay.
I would recommend point slope form. It's probably the best.
Okay.
All right. Yeah. So let me know where you want us to go from here.
Number 13.
Okay.
It's like the same.
Get back to that. Yeah. So the difference quotient of this one's quite a bit more involved, but it's the same process. So you're given some function, and then you have to also find f of, in this case, it'll be t plus delta t.
Yeah.
And so you do modify the letter based on, what's going on there. But so good. So your f of t plus delta t is 3 times t plus delta t minus t plus delta t squared, like that. And that becomes 3t plus 3 delta t minus, and then it's good to, if you don't remember how to do this, to write it out this way so that you can FOIL. And you get t squared plus 2 delta t plus delta t squared, but then you're negating all of that. Just a lot of rewriting. Minus t squared minus 2 delta t minus delta t squared, like that. Okay, and then you're now ready to do the limit as delta t goes to 0. F of t plus delta t minus f of t over delta t, which is equal to this. So I'm gonna copy and paste here. So it's this minus the original, which is 3t minus t squared all over delta t limit as delta t goes to 0. I said a lot. Take a look and let me know if anything there is unclear or
No, yeah, that makes sense.
okay. All right, so from here, you can simplify. Could you take a look at this from here and see what you think you can reduce, or what
You can get rid of 3t. You can get rid of t squared. And then you can simplify 3 delta t and negative 2 delta t into just delta t.
yes, all of that is really good, really correct. And it depends on how much they want you to show. I mean, because I've done this for so long, like I don't know. Sometimes I forget, like, should you show the next line or should you show that the delta t cancel?
Yeah, and
Yeah,
then you
I
can
don't.
simplify on the bottom too.
So it becomes 3. Oops. That's not right. Or is it?
It should just be 1 delta t.
Yeah. Where did I go wrong? Right, so it's 1 delta t. Sorry, there's something not right here. 3t plus delta t. And then that and that cancel. Okay, so there's 1 delta t like you said. There's a t missing. There's a t missing here. That's what it is. So it's 2 delta t times t. Or 2t delta t is probably a better way to do it. When you FOIL. That's why I don't like the delta t's. I first time I made that mistake. So this is 2t delta t and
Oh,
then 2t delta t. So this becomes 3 minus 2t minus delta t, and then it becomes 3 minus 2t minus 0 when you put 0 in for delta t.
it's just 3 minus 2t.
So 3 minus 2t. Now, that is the derivative. Now, the thing with this one is that it's the derivative at all points is a function. So you have to supply it a t value. So you're given an initial value of 0, 0. In the previous problem, the derivative was just a number, so you just use it. So to get the slope is the derivative. You have to put 0 in for t. 3 minus 0, which is 3.
Right.
So that's your slope. Now, again, it's y minus y1 equals mx minus x1. You have your slope, you have your x and your y. So y equals 3x.
Okay. Okay, can we do problem 15?
$15. On a new page. Right. So it says find the derivative of the function by the limit process. That feels like what we've been doing.
Is
But
it, oh, is it just the same? Do we just,
I guess, could you click on show answer for number 15 and check if they're using the definition of the derivative like we've been doing that limiting stuff?
yeah,
It might be worth showing you this one just because it's a little, this one's maybe awkward.
it just says f of x equals 0.
Okay, let's do it. So the limit, it just says show answer. So limit as delta x goes to 0 of f of x plus h minus f of x over h. So f of x plus h, this is gonna be a little bit maybe awkward, but there is no place to supply an x. So it ends up just being the same thing. Since there's no x to put the x in, there's no x to put x plus h in, so it's just the same thing. So why that matters is when you write this, limit delta x goes to 0, f of x plus h is 7 minus f of x is 7 all over h. Well, sorry, not equal sign. The 7 minus 7 is 0, 0 over h is 0, so the whole thing becomes 0, which is the derivative. The derivative is 0. So this, when you read it, you got to read that prime there. That prime there means derivative.
Oh, yeah.
It's a subtle thing, but it's going to show up in the rest of the course.
And then a 19 would be the exact same. 3 is the same. Okay, can we do 31?
Have you gotten any, did you get any sort of test review go into,
No,
okay. All right. So 31, again, I got to ask here, are we using the definition of the derivative or derivative rules? There's this transition at some point in the course and
no, I think right now we're still using definition of the derivative because 2.2 is the derivative, like that's like the constant rule, the power rule, the constant multiple rule, right? Sum and difference rules.
so the f of x plus h here is pretty, is it okay if I use h? I'm gonna, or do you really
Yeah,
want delta
no, that's
x?
fine.
Okay.
That makes it a lot
Okay.
easier anyway.
All right, so it's x plus h cubed, and this means x plus h times x plus h times x plus h. And so there is known expansion properties on this, but this becomes x squared plus 2xh plus h squared times x plus h. So this becomes x cubed plus 2x squared h plus xh squared plus, and then you keep going here with everything, multiplying everything by h. So you got h x squared plus 2x h squared plus h cubed, like that.
Okay.
All right, so that's a biggie, but notice everything has an h in it basically,
Mm-hmm.
which means that They're all gonna go away once you cancel
Right.
and talk about once things kind of like once we do the subtraction. So you got to do this limit as h goes to 0. And so you grab all the stuff we just did, all this stuff, you subtract out the original. So the original is this x cubed all over h. So the x cubes cancel, and then everything with an h in it cancels.
Right.
So you end up getting 2x squared. Doesn't seem right. Sorry, I'm way off today. Oh, there's a third there. I see, that's why. So these two are actually the same.
Yeah.
So this ends up being 3x squared h divided by h, or 3x squared plus xh plus 2xh plus h squared. And then when you put 0 in for h, you just get the first one, and then everything else goes to 0.
Yeah. And then we just substitute that in for the formula again.
Yeah, you got it. Okay, so okay, so that's part A.
Yeah.
So part A is the derivative is 3x squared, and then we're given this point -1 comma 4. So to find the slope at that point, you have to put the -1 in.
Yeah.
F prime of -1 equals 3 times -1 squared equals 3. So the slope ends up being 3. Now, keep this in mind. There is another way to do the difference quotient at a point. It's really similar, but instead of putting x in, you put the number in. You put in -1 plus h or -1 plus delta x, the x value. I don't know if you'll see that or not.
Okay.
Okay. So now we have enough to write the equation of the tangent line. Y minus 4 equals 3 times x plus 1. All right, so that is part A. Now to do part B, have you used Desmos before? I know you got a graph calculator. Have you used Desmos?
Yeah.
Okay. So let me just graph it here. The original was x cubed, and our graph here is y minus 4 equals 3 x plus 1. Something's not right. Wait, are we doing 31?
Mm-hmm.
All right, so that's the problem, is I used the wrong point.
Yeah, I was gonna say I thought it was 2.8, but then I thought maybe I was looking at the wrong thing.
No, and I do make mistakes.
No, that's okay.
I'm definitely having some issues. Been having issues all week, but nothing to do with you. Just when you're tired, you don't function well. So this is y minus 8 equals 12 times x minus 2, like that. And so like when I went to graph it, it wasn't tangent, and that's the whole point of this, is it's
Right.
supposed to be tangent. So if it's not tangent, you got a real problem here. All right, so let me snip this in here so you can see it. Here we go. So here you go. You got the red, you got the blue, and their
Yep.
tangent right there at 2 comma 8. So If you remember from geometry, tangent literally means it touches at one point like that. That's what it was. That is the definition of a tangent.
Okay. Mm. And then if we look at 37, the one that shows like the box, is that like the same thing, it just written differently or?
Let me look here.
No,
We,
you're
we
good.
didn't, and just to be clear, like we didn't do, well, we kind of did. Part
Yeah,
C.
and that
Yeah,
kind of question probably won't show up on a test just because he doesn't make us like submit any like written
yeah.
answers. So we would have to pick from like a graph about what looks most similar and I'd just be able to plug it into my calculator or something.
Okay, so which problem did you say? 57?
Sorry, 37.
37. I'm sorry I keep asking you to repeat stuff.
No, you're okay.
I'm really bad.
You're
All
good.
right. So this one's similar. Yeah, you are going to. You have to take the derivative of the thing on the left. That's the first part.
Okay.
Okay, so that's where you got to do your difference quotient again. Definition of derivative. That's minus 1/4 x plus h squared, which becomes minus 1/4 x squared plus 2xh plus h squared, which is minus 1/4 x squared minus 1/2 xh minus 1/4 h squared. So then again, you got to go do the limit as h goes to 0. So you grab all this stuff. And you don't do this the whole rest of the course, by the way. Like this is, you only do it now and then you never do it again. You might wonder, well, why am I even doing this? I can't answer that question, but that is what you have to do here.
I'm like, that sucks. I've spent a week learning it and I'm never going to use it again.
And then you forget it, learn it and forget it. All right, so what this does is it cancels this one and this one, and then
all the
you divide. So you get the limit, h goes to 0, minus 1/2 x minus 1/4 h, which becomes minus 1/2 x minus 0, or minus 1/2 x. Now this is where, so you, like probably by now you're comfortable with this process of taking a derivative. You're seeing me doing the difference quotient or definition of the derivative. You will be asked to do a variety of things from this place. So this is this is where the instructions come in. So let me snip those in here again. It says, find the equation of the line that is tangent to the graph of f and parallel to the given line. So parallel means that it has the same slope. So we need to go back to this equation on the right, x plus y equals 0, and determine its slope. Y equals minus x. So the slope is negative 1, which means you're setting the derivative equal to -1. So x equals 2.
Okay.
So the good news is that we now know 2 things. We know the slope, and we needed a point, and we now have a point. So to get the y value, you have to go back to the original function, minus 1/4 x squared, like that. So it becomes f of 2 is minus 1/4, 2 squared becomes -1.
Okay. Yeah.
So now to write the equation, we have everything we need. We have the slope. We know that y minus y1 equals m, x minus x1. We know that We know that, let's see here. Y plus 1 equals x minus 2. So that the point is 2 common -1. And then the slope, because the slope is parallel, it's got the same slope here, which is
-1.
-1. And if you forget that, you can always go put the 2 back into the derivative and get that information.
Right. Okay, now we're gonna switch over to 2.2, which for me was the easier of the two lessons.
Good.
So we could start with number 11. I have like the idea of how to do it. I was just getting like super confused with the switching of the like, because when it's negative exponent, it becomes a fraction to keep it positive. That's where I was
Okay.
getting confused. So it's like, is that one loaded for you, or do you need it
Yeah,
to?
I've got maybe starting at 9, looks like.
Yes, 9, 10, 11, 12, 13. And
Okay.
then you need the directions for that one. I can tell you what
I
they are.
assume it says just determine the derivative.
Yeah, it's just yeah. Yeah, finding the derivative of them.
Okay. Yeah, so the first thing you need to know is there's these derivative rules. dx of x to the n, that's x to some power, like 7 in this case, becomes n, you bring the exponent out in front, x to the n minus 1. So here's how this works. The derivative is, and there's a lot of different notations for the derivative. Y prime is a notation, d dx is a notation, f prime is a notation. There's a lot of notations. Don't try not to get too caught up on that. Just write something down.
Yeah.
You bring that 7 out in front,
7
and then you
x
subtract 1
to
from.
the 6th then.
So this becomes 7x to the 6th. And in time, you will just write 7x to the 6th.
Okay.
Basically, as soon as you learned it, you'll be moving on to harder stuff and you'll say, oh, yeah, I
Yeah.
got it. So can you tell me the derivative for number 10?
So that would be 12x to the 11.
Yes. So you want to write something like y prime equals 12x to the 11th.
Yeah.
Now for 11, and for a lot of these starting with 11, there's what I call a rewrite step.
Okay.
Not a calculus step, just a rewrite step. This is things you learned in pre-calculus, college algebra, whatever. So you're rewriting y. You're not taking a derivative, x to the -5. Because it has to be in the form of this, where it's x to the n. And that
Right.
is the case here. So y prime is now -5x to the -5 minus 1. And until you get super comfortable with this, I would recommend writing it this way. -5x to the -6. And then sometimes, like if you were taking a multiple choice test, it might be written this way where the exponent is on the bottom.
Yeah, that's how it is here.
The instructors will generally take this though. Like
Okay.
you don't have to overdo it.
Okay. And then number 23.
So there's a bunch more though, like 12, 13, these are all variations on sort of the same thing. I mean, we can go to 23, but like you're jumping through a bunch of problems. Just letting you know. Like I'm happy to go to 23, but just keep that in mind.
Oh, like you think it's important to look those over, or?
Yeah, there's usually a lot of confusion about how to deal with roots and other things. Um,
Isn't a
y-
root just a fraction as a exponent?
yes.
Okay.
And what if the root is on the bottom? You just have to be comfortable with this rewrite step.
Okay.
That's all it is. Like I mean, it's not really complicated if you're comfortable rewriting it. If you are not, then yeah, you're gonna really struggle. So
Okay.
Yeah, let's look at 23. So 23, the derivative rule here is that d dx of sine x is cosine x.
right,
That's a known rule.
yeah,
And I might as well send this to you over now. There's a really good table of derivatives and integrals that you ought to have. I'll copy that into the chat, and you can take a look at that, print it out if you want at a later time, have it with you.
okay,
Now there's more, there's like, it's like this rule I just wrote here is correct, but there's see how there's a constant in front. So there's this other rule which says d dx of a constant times f of x. The derivative is the constant times the derivative. So in other words, in your problem, if the constant's going to come with it for the derivative,
right.
and then you're taking the derivative of sine x or sine theta, which is cosine theta, like that.
Oh,
And you
so
if you
that's it. You just,
and if you're looking at the rules, like both of these rules are in there.
yeah,
This constant, the constant's actually the first one that you see. Power rule is the second. They look a little overwhelming at first, but about 3 or 4 days, you'll know them all, or should know them all. All right, so where should we go from here?
can we just do 22? I want to make sure I know how to do those correctly. I'm
Sure.
pretty sure I
Yeah.
do. But let's just double check.
Yep. All right, yeah, 22, you said?
Yeah.
All right, why don't you try it? So this one, uh, it is power rule like we've been doing.
Hmm.
So there's the ddx of x to the n becomes nx to the n minus 1. ddx of a constant times x to the n becomes n times c x to the n minus 1. So whatever that exponent is, you bring it down and multiply. So this 3 is going to multiply the 2. The 2 is going to multiply the 6. Now, a rule we haven't covered yet is that the derivative of a constant like -1 is 0.
Right.
So do you want to try this one or tell me what you think the answer is based on this?
Yeah. Is it just 6x squared plus 6x?
Yes. No. You have to bring that 2 down and multiply the 6.
Oh, yeah. Sorry, 12x.
You got it. And then notation y prime equals like
Right.
that.
Okay, perfect. Mm. Can we do 31?
Sure. Find the slope of a graph and find the given point is derivative each graph should confirm result. Okay. So 31, we're going to look at the function on the left. So we've talked enough about this. Could you attempt to find the derivative? And I would recommend doing a rewrite step for this
Yeah.
first.
Do you just make it 8 over 2x?
No. So you have to rewrite this as 8x to the minus 2.
Oh, okay, okay.
That's what I was referring to. You want to rewrite before you take a derivative.
Oh, okay. Okay, yeah. And then would we take the derivative after we found that?
So, and that's what I'm asking you to do here.
Oh, okay. So then it's just negative 16x.
To what power?
Yeah.
What is the exponent?
1.
So again, you're subtracting 1.
Oh, no, it's negative 3.
Yes.
Yeah.
So some students don't do well in calculus because of exactly what you just did there. I don't know exactly what it is, but it's so easy, and you can work the rest of the problem, get numbers and think you're right, and it's completely wrong. So
Yeah.
just keep that in mind that like we did not do near enough practice on these, but it's okay. So now, because we're trying to find the tangent line, it says the slope of the graph, sorry, just the slope of the graph. So the slope is the derivative. Slope is the derivative, but we want it at a point. So this becomes, we want to evaluate the derivative at 2. The reason it's 2 is because that was the given point. It's always the x value. So f prime of 2 is minus 16 over 2 cubed, which is minus 16 over 8, which is minus 2.
Okay.
That is your slope. That's all it's asking for.
Oh, okay.
Sometimes it wants you to write do the equation.
So we do 35.
Sure.
It's similar to the last one.
This is a new, it kind of looks like a new type of problem here. So you will learn in one of the future sections how to actually take the derivative of this. But for right now, you have to do a rewrite step, and your rewrite could be, in this case, foiling, expanding this.
Okay.
So when you foil this, you get 16x squared plus 8x plus 1. Now you can take the derivative because you know how to do it, but you don't know it in this form. So if you look at something and you don't know how to take the derivative and you're pretty sure it's not a rule, then you have to do some sort of manipulation
Okay.
on it. So what do you see here? What
So 16 times 2x to the 1 power. is- So the 1 becomes a 0, but then the 8x becomes 8 times 1 x to the 0 power. So that just becomes 1. So it would be 8 times 1, right? But then we wouldn't have like a number. So would we just get rid of the 8 then?
no what you said. So if we let's work this out kind of like fully so you can see it. 2 times 16x to the 2 minus 1 power.
Yep.
Plus 1 times 8x to the 1 minus 1 power plus 0.
Yep.
So 2 minus 1 is 1. 2 times 16 is 32. So 32x. Now x to the 0 is just 1.
Right.
So this becomes 1 times 8 times 1, which is 8.
Oh, so we would still keep the 8. Okay. I was just wondering because I know that with the 1 you get rid of. So I didn't know if it was just because it was like a regular number or not. If you would get rid of it.
Yeah, so from here, you do have to evaluate the you do have to evaluate the at the derivatives. You have to put 0 in for x. Y prime equals 32 times 0 plus 8 becomes just 8, and that's your slope.
Okay. Yep.
think that's all it was asking for.
Yeah, it's the same direction, just to find the slope.
Okay.
Can we do 41?
Sure. Um, and the derivative, okay. Yeah, so 41 requires a rewrite step here, and that's just using your exponent properties, which I'm happy to cover if needed. But you say, okay, g of t is really t squared minus 4t to the minus 3 power.
Yep.
And now you just take your derivative, just like we've been doing. So why don't you give this one a try and see if you can come up with the derivative.
Okay, would it be 2t over 12t to the 4th power?
So it's the first one is 2t.
Yep.
Plus 12t to the minus 4 power.
Yep.
And then if you wanted to rewrite it, good, like you just said, it would be 12 over t to the 4th.
Oh, okay, so that you just put the you don't put the
Yeah.
entire thing over, you just put the okay.
Yeah, just the one.
Okay. Okay, perfect. And then, oh, you just find the derivative. Okay. Can we do 47?
Sure. Yeah, so at some point soon you'll have a way to do this the way it's currently written, but right now you don't. So you need everything to be like x to some power. That's what you're looking for. So the only way to do that here is to distribute in
Okay.
first. And then you get x cubed plus x.
Yeah.
Still no calculus. You haven't taken a derivative. What is the derivative for this place here?
Three x squared plus 1.
Right, that's it.
Can we do 49?
Okay. Yep. Okay. Now this is one of those I was kind of referring to earlier where you gotta be comfortable with the roots. So before I do this, I will remind you that the square root of x is really a 1 here and a 2 here.
Yeah.
So it can be written as x to the 1/2. And I always remember this one as my reference. There's others you could use, but you rewrite again. You rewrite as x to the 1/2 minus 6x to the 1/3.
6x to the 1. Oh, I didn't even see that 3. It's tiny.
Maybe the way you're viewing it, I don't know. There's been a lot of like things that have been cut off.
Yeah, I don't know why. I like the book, like some questions are like written normally, and then the other ones, some of them I take pictures of them, like because I don't screenshot them, I just take pictures with my phone. But like just the way they're written within the book are like totally screwed up. I don't know why. And it's always hit or miss. It's always like some chapters have that problem and then the other ones don't.
Now to take a derivative, you have to bring the exponent down and subtract one. I mean, this is one of those little things like if you're not really like people think they're calculus ready, but you should be able to quickly subtract one from that. And you should be able to take 1/3 and quickly subtract one and get minus 2/3. So maybe not that fast, but you shouldn't be like uncomfortable manipulating fractions.
Right.
So see if you can work this out and see what you come up with.
Okay, so. um, So it's half x to the negative half minus 2x to the negative 2/3. And
You know, where
then-
this gets potentially more complicated here, and we are essentially out of time after this question is like if you would have to rewrite it. So
Yeah,
you know, are you okay with the idea that all right, it's 1/2 1 over x to the 1/2 now, and this becomes
Yeah.
1 over 2 squared of x, and then same thing here, minus 2 over cube root of x squared. That's your derivative. All right, so we do have to stop here for today.